so today we're going to be going over the standards for my unit plan that I decided to do. I'm doing 6th grade expressions and equalities. So today I'm going to be starting with 6EE1, and the standard is write and evaluate numerical expressions involving whole number exponents. So my objectives for this lesson are the students will be able to identify numerical expressions with whole numbers, and the students will be able to write their own expressions using the knowledge of whole number exponents. So I wanted to begin by using a Math Antics video that kind of sums up what we'll be learning today. I love this Math Antics guy. We use him in my observation classroom, and he explains things very well, especially for the students and grabbing their attention. So I'm going to go ahead and play just a short piece of this, and then we'll get started.
Hi, welcome to Math Antics. In this lesson, we're going to learn about an important math concept called exponents. Sounds kind of weird, huh? Indeed it does, my good man. And I'm afraid it's because you're pronouncing exponents incorrectly. The proper pronunciation is indices. Indices. Oh yeah, that's right. In a lot of countries, exponents are called indices. But the good news is that the concept is the same no matter what term is used. And since I'm usually an American, I'll usually use the term exponents in this video. But I'll occasionally point out the other terminology too. Sound good to you? Jolly good, sir. Toodle-pip. All right then. Well, what are exponents, or indices? Well, just like the four main arithmetic operations that we use in math, exponents are a type of math operation. They tell us what to do with numbers. Okay, but what do they tell us to do? Exponents tell us to take a number and multiply it by itself a certain number of times. In other words, exponents are basically repeated multiplication. To help you understand what I mean, let's review multiplication for just a second. Do you remember how multiplication is basically repeated addition? For example, 2 times 4 is a shorthand way of writing 2 plus 2 plus 2 plus 2. It's the same as 4 2's being added together, which equals a total of 8. Now, let's compare that to a similar exponent. Yep, that's an exponent. And in a minute, we'll talk about why it looks like that and why the numbers are different sizes. But for now, you just need to know that this exponent tells us to take the number 2 and multiply it 4 times. In other words, you would take 4 2's and multiply them together. 2 times 2 times 2 times 2, which would equal 16. So, multiplication shows repeated addition, and exponents show repeated multiplication. And we'll see more examples of how exponents work in a minute. But first, let's talk a little bit about why exponents look the way they do. Exponents involve 2 numbers. The first number...
Okay, so he basically just went over how the whole number expressions, the 2 times 2 times 2 equals 2 to the 4th, that just explains how exponents work. So, I wanted to do a problem together that kind of just sets the mood on how these are going to work. Okay, so I'm going to use 3 times 3 times 3, and so on and so forth. And then what would this equal? So, in order to solve this problem, since they're all being multiplied, that's how you would figure out what power your exponent is going to be in. It's not like addition, where you just add all of them together. Like you said, you're going to be multiplying them all together. So if we were to add how many 3's there were, we would be able to 3 to whatever power that would be. So if we count, we have 1, 2, 3, 4, 5. So our answer would be 3 to the power of 5. So this will come in handy later on in this unit when we learn the order of operations, and I can explain that a little further next time. So I wanted to do a couple problems as a class to kind of get you used to this and what you'll be doing for your class assignment. Okay, so let's see, we have 4 squared. Let's do this the opposite way. So if we were given the product, we need to find out what it looks like as an expression. So if we have 4 squared, the squared or to the second would mean you would have to have 2 of these. So it would be 4 times 4, because now you have 2 4s. So if we had the problem, 2 times 2, let's see how many we have here. How many I wrote. Okay. So if we count how many 2's there are, if we have 1, 2, 3, 4, 5, 6, 7, how would we write that expression?
2 to the 7th
Yes.
power.
We keep our main base 2, but then our exponent would be to the level of how many 2's there are. So it would be 2 to the 7th, correct? Alright, I think we have one more to do together. Okay, so if we have 10 to the 4th, how would we write that out as expression?
10 times 10 times 10 times 10.
Yep. So that means we would have our base of 10, and we would write it out 10 times 10 times 10 times 10, 10 4 times. So this lesson is not too difficult, but it's just, you just need to figure out how many times you need to expand those numbers. Okay, so for the students' independent practice, I did not bring it with me, but it will be attached in my file. So it's going to be a worksheet that the students are going to, there's 10 problems, and the students are going to do the first 5 problems on their own, and then the next 5 problems for the closing, they will use, they will do in a group. And that's when they will do this together, and then that'll give them the chance to kind of just figure out how all their minds are working and how they each figured out the problem, and then it'll also give time for them to ask me questions. So I think that'll be a good exercise. And for my upcoming lessons, so I plan on doing 6EE1 today, and then I will continue on with the next couple standards. There's one that I might split up, but we'll go from there. And let's just do one more problem and we'll end there. Okay. So let's say we have 5 to the 4th. If we were to expand that, what would it be?
5 times 5 times 5 times 5.
Perfect. Alright, so we pretty much get the concept.